Hi everyone, this is the third section of the course of Persistent with C++ and Qt. This is Carlos, and now we're going to start with the inference kernel set video. So the first thing first, we're going to create a new function in the inference kernel. It's called Modus Ponens. So you might remember that the Modus Ponens is where you have a rule and the antecedent and the consequence are cubes, and the cubes is a series of AND operations. So then when we finish to define that, we might go to refactor and add definition of select class. Didn't work as I suspected. Refactor, great, and great. Here we are. So I would like to start giving a log of when it's entering this method. Is if maybe all these tests that I did in the project affect my way to see these functions, and I wanted to ensure every time that a function is entering. So doing some logs might help a lot. After this log, we're going to create a node type from the tree and based in the entry that we pass parameter. Get tree. Add entry. Great. Next step, we're going to define first and second, because we're going to use it for the antecedents and the consequent part of the entry rule. So next, it's just an if get type and compare it with the prop not if. You may remember the operation if defines where I think that is the highest entry, the highest node of that represents a rule. So that's the reason that we are comparing as if there is something else. Just return 0. Okay. Inside of the if, we're going to assign to the first, and the rule is cube, not at first, and second is cube, not second. Great. And the only thing that we need to do is to compare if it's not equal to 1, it means that is not a cube. It returns a boolean. We also might want to do this, compare it by true, because actually it's a boolean. We don't need to open brackets. True. And we're going to return 0 or false, saying that the rule defined by the entry is not able to use with Modus Ponens. This is going to be very useful for the forward chaining algorithm. And the step is to insert it to the rules. Rules type, insert workspace, rule type, and is Modus Ponens, and a short log saying the rule entry is Modus Ponens and line answer, and and return true. So what's next? I would like to check in the test unit if we have two real cases. That is one that is not a cube or is not able to Modus Ponens, and other one that is able to Modus Ponens. So we can say here void is able modus cube rule. If it's a cube rule and this is not a cube rule, Modus Ponens not cube rule. I just need to stay underscore here and then go to refactor and say a definition inside the class. So you can do this. Actually remove this part and say eica.compile inference kernel ekTP, and the only thing that we're going to do is to verify if ik is able Modus Ponens. 9 is the index of the if operation. Go again to refactor, add definition outside the class, and we're going to do pretty much the same, but we're going to refer to an index that's different. It is the 19. Run the test. I think that I need to compile the inference engine. I think so. Yes, I know it. So good. Yeah, it's lasting a lot. Let's continue seeing the application output and see if cubebook and pass disable Modus Ponens cube rule. If passed, disable Modus Ponens no cube is passed. Okay, so I think that we have an error here. Why is passing this? It shouldn't. Let's put a breakpoint here. Yes. F11. Yes, I found out that we need to do an OR operation because it's the inverse. I did in the previous part I did something like this where asserting that everything is true, but in this case it's not. So if any of these or both operands aren't 1, then it's going to true that it's not a cube. The problem is that I need to rebuild again and wait a little longer. But now I'm pretty sure that it's going to work, because even if second is not 1, it's going to throw a false. So if we run the application, it says come on. Yeah, it's gonna having problems here. Something that's pretty much easy. Second. Why not? So we continue. I think that we need to rebuild the whole project, starting with the Pro Compiler v2, then the Inference Engine v2, and at the end the test inference kernel. And the point that is going to throw an error saying that the I key is ever Modus Ponens 19 returning false. That's what we were expecting. So that's it, and in the next video we're going to continue with disable Modus Ponens. That's pretty much the same, so it's going to be a short video. So see you and thanks.